Hello friends, this is Pratik Prasoon. I am here to deal with the chapter Newton's laws of motion. I will be taking care of all the syllabus, all the important topics related to this chapter. And once very big in the beginning page, which I experienced during my teaching period of time, that once you are covering the whole video session in a proper manner, which I am going to teach you in coming videos, whole section, once after getting the complete understanding, I believe you won't have any sort of questions rising in your mind. Again, I am sharing that I will be covering from micro level concepts to the macro level concepts, not leaving behind even the single concept related to this topic. So the topic will move ahead in the pattern, like I will start from the constraint, because constraint is very important. Unless you are very clear with the constraint relations of the objects, you cannot move ahead in the Newton's laws, because laws of motions questions and its applications, and to understand more deeply the concept you need to go with the constraint relation. So the first one will be the constraint relation, where I will be dealing with the constraint on string and wedge constant. The next one will be the different type of forces that is existing, because as you know the laws of motion are related with the forces, and these forces comes in action, comes in reality once you are knowing with the different type of forces. Again, after completion of the force section, I will be coming on the laws of motion, that is the first law, second law and third law, with complete and full explanations. But before moving ahead, I will be sharing that video will be divided into two sections, the one with the fundamental concepts and the next one with the advanced level. So please go through the video in a proper way, don't skip, because if you are skipping you may be missing some of the concepts. So let's begin with the videos, and I believe that once you are coming across with the videos, you will understand all the facts related to this chapter. For watching the full video of this chapter, I am giving the link in the description box mentioned here. You can take the complete session from the link itself. So the topic is laws of motion. As I've already mentioned you people, that the proper channel which we will be moving is already has been mentioned in the introduction session. So the topic starts from constraint motion. This is very important to understand, because unless you are clear with the concept of constraint, you cannot go, or you cannot be very strong in laws of motion problem area. So this constraint motion has been divided in two parts. The one is the constraint on string, constraint on string, and second one as wedge constraint, wedge constraint. I will be discussing both the concepts, and in parallel I will be sharing some examples also, and different sorts of questions also I will be dealing. So the first one starts here is the constraint on string. String means a rope, and there is a pre-assumption here. One pre-assumption you should mention here, pre-assumption, that the mass of the string, is 0. There is no mass in the string. So suppose this is a string, which string is the combination of smallest particle, and I am pointing out this point as A, this point as B, C, taking some random points D, E, some F, and this one as Z. This constraint have three conditions generally occurring. Constraint, as I already mentioned you people, that if you find the meaning of the in the dictionary of the constraint, the meaning of the constraint, it is a tight. So string can be a loose, can be in a situation to break, or can be in a standard situation. So there are three conditions for this rope. The first one, suppose this point is moving with velocity v. I am naming this as Vg, this is Vf, this is Ve, this is Vd, Vc, Vb, and this one as Va. So suppose this A point is moving with velocity Vg, this point is moving with velocity Vf, this point is moving with velocity Ve, Vd, and simultaneously all the points. If you will try to understand, if I am taking the velocity of this point Vg, and Vf, there is a certain distance existing between these points. Let this point distance be small d. So if Vg is, there are three conditions, means if Vg is greater than Vf, if Vg is greater than Vf, it means that the velocity of G point is more than the velocity of F point. It means this G point will be moving faster with respect to the point F. In this case, this point will have the tendency to move in a faster manner, resulting in the tightness or stiffness in the length of the string. And this tendency will come in conclusion with the fact that string will have the tendency to break. So this is the condition where this will be moving with fast speed and this one will have the slower speed. So this length will be in a very tight condition and there will be a tendency to have a breakage in the string level. So suppose if Vg is greater than Vf, or I should say Vf is greater than Ve, all the consecutive manners corresponding one with the previous one having the better velocity or more velocity will have the condition like this only. Again, if I am sharing this Ve is greater than Vd and simultaneously all the points, this condition is will come when the string will have the tendency to break. String will have the tendency to break. The next point is coming here is, again I am mentioning that you should follow out the videos in a proper manner, and for better suggestion, for better understanding, repeat the videos for 2 or 3 times, you will understand the different facts. The second point is, suppose I am again taking the same 2 points G and F in the beginning to make you understand. Suppose this Vg is less than Vf. In the previous condition we had Vg is greater than Vf, and this next condition is, I am taking this the reverse process, that is Vg is less than. What is the meaning of this? Now you see, this point will be moving with slower velocity and this point will be moving with more velocity. It means this will be moving in particular time, this will move more distance, and in that same time this will move less distance. So movement of this with higher velocity will reduce the displacement between the 2 points. It means this point will be moving with higher velocity and this point will be moving with lower velocity, reducing the distance between the two. And in this condition, if the distance between the 2 points reduces, it means the string becomes loose. So this is the condition, or I should again say that Ve is less, Ve is greater than Vf. I am just taking the reverse of the previous one, that all the points in proper manner. In certain conditions, in these conditions, the string will be loose. String will be loose. The next point comes that if I am taking again the point Vg and Vf, it means if I am carrying that this, if Vg is equal to Vf. Now look here, this is the point which we are going to discuss in constraint. Suppose the 2 points is having the same velocity, it means in particular time the amount of distance, that amount of displacement or distance that this block point will travel, the same displacement will having for this block. It means this distance will remain same throughout the motion of the particle. That is, if Vg is equal to Vf is equal to Ve is equal to Vd is equal to Vc is equal to Vb is equal to Va is equal to some generalized velocity V, it means all the points on the string will be moving with the same velocity, resulting in the same displacement, the static displacement between the corresponding points. And this is what the condition where the string remains tight, and this is constraint. Here string remains tight, and this is what constant. This is what we are going to study in the constraint of string, that all the particles of the string will be moving with the same velocity or same acceleration. Remember that this velocity constraint is as same as for the acceleration. The same relation can also be implemented for acceleration part also. This is the basic structure of the string, how these things happen. Now if I start with the starting point, that is a string concept, that one important point which we are coming here in conclusion, that the velocity components or acceleration components of all the points existing on the string will be same in constraint. So the two basic repeated concept that is existing, which has been summarized from the small session, is one, the string will be massless, and The next one, that the velocity components of all the points on the string along the motion of the body will be same. That this is the condition, this is the third condition which will be handling all this constraint. These two conditions are not constraint, these are some of the concepts you need to understand how points are moving. So I will take one example. Suppose I am taking one string. Again, this is an example session. One block is this one block, and this is one block. This is one and is m1, this one is m2. If I am saying that this block is moving with velocity v and the string is constrained, and the string is constrained means all the points along the direction of the string. You just remember the point. This is very important point. Every time, sometimes you just remember the point and points generally comes in mind. So the point I am repeating again that if the string is constrained, that all the points on the string will have the same velocity along the direction of string. This is very important, along the direction of string. So this is the string direction, this is the string direction. This block is v2 is moving. So this point, this point, this point, this point, all the points will have the same velocity. So this point attached to this mass m1 is again on a string. This point is very common to mass m1 as well as m2. So since all the points on the string have to have the same velocity, it means this point will have the velocity v as with respect to m2. So this m1 will have the same velocity as v. This is what the complete explanation or the summarized form of this video is. Now I am taking one more example. Another example for this string coordination, I should say, like suppose one block is here. Suppose this is one block system, and this block is connected with this string with a small pulley. I will be discussing this pulley in separate chapter. This is the block. This one is m1. This one is m2, or I should turn the page for better explanation. Suppose this one is the example I am taking. This is the block kept on any object, on any table, connected with a pulley, moving in this direction as shown. This one is m1, this one is m2. This is the horizontal ground, and this angle has been given some theta. Now the question arises here that if this block is moving with velocity v, the question is that if m1 block is moving with velocity v, what will be the velocity of the block m2? So again, this is a constraint relation, because this m1 will be stretching out this string, and the amount of velocity that is existing in the string will be responsible for the movement of the block m2. This is clear, as we have already mentioned in the constraint relation. Now one important point which I have mentioned, that is the summarized point, that the velocity components of all the blocks along the direction of the string will be same. If we visualize the question is in the manner that if this block is moving in this direction, this m2 block will have the tendency to move in this direction, because this is not exactly on the vertical point. So initially, in the beginning phase, this block will be moving in this direction until this block is coming here. But the question is, what will be the velocity of this m2 block if the m1 block starts moving with velocity v? Now question is very simple. Again, the same concept is the concept which I have repeated again and again, is very important to understand, because one sentence plays a vital role in solving the various type of questions related to the laws of motion. Suppose this block is moving with v. So this point connected with the string will be moving with velocity v. All the points on the string will have the velocity v in this direction. This point, if I say about this point, this have the velocity in this direction, and similar way this string and this m2 block have the common point of contact. So since the string has to move with the same velocity, so this point will be moving in this direction with velocity v. But actually this block is moving in this direction. So what can we do? We can take the components of this velocity in this direction, and that will be equal to the velocity of string. That is, if I am taking the component of v2 as in this direction will be v2 cos theta. v2 cos theta is the velocity of this point in this direction. But as per the previous explanation, that all the points on the string is moving with the same velocity v, so this v2 cos theta will be equal to v, and if I am finding out the velocity component, that is v2 equal to v upon cos theta, that is v sec theta unit, or I should say meter per second. This is the very finest example. This has been asked in various examinations. Similarly, one more example I will be sharing. I hope you people will be understanding the fact that how this string relations or constraint relations are identified. Remember that this constraint concept is valid for the acceleration as well as velocity. I am here taking the example through velocity, but in further classes when I will be introducing more questions or Newton's second laws, there velocity will be less to be implemented, acceleration will come in figure, and the same constraint we will be applying in this concept also. One more example I will be sharing, that suppose this is a rod, this is a massless rod, and one clip is attached to this, one movable clip is attached to this. Suppose one string is attached to this and going through a fixed pulley session, and here is one block is attached of mass some m. The question is that the m block is moving with velocity v. They have mentioned some angle also, theta. In generalized, everywhere I am taking theta, you can take any angle. They can, in examination they can put any angle, 30, 45, 37, any of the examples they are sharing, the same process will be there. Suppose this m block is moving in down direction. So the question is, what will be the velocity of this clip? Since this clip is attached to this rigid rod, and if this m block is moving down, it means this, what you need to observe actually what will happen. Physics is all about to understand the reality that is existing, that is happening. We should not move according to the concepts that if this has been mentioned, this will happen. No. Every time you need to visualize. Easily we can identify in this question that if this block m was moving down, it means this clip will be moving in this direction. Let the velocity of this clip as v1. Now very simply again I am applying the constraint relation as, if this block is moving with velocity v, it means this point will be moving with velocity v. All the points will be moving with velocity v in downward direction. This point will be moving with velocity v, this point will be moving in this direction v, this point in direction v, and again this point will be moving in this direction. So along the string the velocity components will remain same. Now again the same concept we should apply, that this is the actual velocity direction of the string of the clip. We will take the component of this velocity along the direction of the string. It means here we can write it as v1 cos theta, because the component of this velocity along this direction will be v1 cos theta, and direction will be in this only. So v1 cos theta is equal to the velocity of all the points on the string equal to some v. Again we can easily find as v sec theta meter per second. This is one of the examples to get the relation or to find the velocity or acceleration of the two blocks attached with the string. This similar manner we can move in different facts also. Again I can share one more example to have better clear of concept. Is suppose this is one pulley. I will be sharing this pulley concept in later stage. Just after this video I will be discussing this pulley. Suppose this pulley is attached with two string system. This is mass m1 and another is mass m2. This is ground, and both the blocks are kept in this direction. The question is that this block is moving with velocity v1. Again I am mentioning some angle. This one is theta 1 and this one angle is theta 2. They have mentioned the velocity component of one of the blocks. Now they are asking, if this m1 block is moving with velocity v1 in particular given direction, what will be the velocity of the mass 2? The constraint relation is all about this application only. The only single point that has to be in mind is that the velocity components of all the blocks along the direction of the string will remain same. Let's start with the point to identify the solution of this question. That again we have, let me clear on this page only. that this V1 is in this direction. Let the velocity of mass M2 is V2. What we have learned here is that the velocity components of all the blocks attached to the string will have the same velocity along the direction of string. This is very important point. Every time I will be repeating this. This is the only point that is existing in constraint. If you are clear with this concept, multiple blocks can be attached and we can easily identify the relation between the two blocks. Now you look out the pattern which I am solving. This is the last example I will be sharing. I will give some assignment also. You can try in from your own level. Now you understand. This is the velocity of V1 in this section. What we have learned, that the block's velocity along the direction of the string will be same. But this velocity direction is not along the direction of string. Along the direction means either in this side or in this side. This is along the string. Either in this side or in this side. So suppose if this block is moving in this direction, it means the component of this velocity along this string is this. If this one is theta, so from mathematics this one will also theta. So the velocity component of this block mass m1 along the direction of string is v1 cos theta, theta 1. I hope you will be now having clearance with the constraint how I am identifying the relation. Now this point along this direction has velocity v1 cos theta. Similar manner, this point will have the velocity v1 cos theta in this direction. So all the points will be moving in this direction with the amount v1 cos theta 1. Similarly, if we are going to string this point, according to constraint, this will be moving in this direction with v1 cos theta 1. This point again will be moving with v1 cos theta 1. This point will be moving with v1 cos theta 1. This is what the explanation. Now, this you just look out here. This point is the point of contact of the string with the mass m2. And since this m2 is moving in this direction, so if we have assumed the velocity of this block v2 moving in this direction, means if we are taking the component of this velocity along this direction, this will exactly give the relation, and that will be the same velocity for the string. That is, it means we are applying here as, you just look out the questions in parallel, that if we are taking that is v2 cos, this implies v2 cos theta 2. I am taking the component of this v2 along the direction of the string, because the velocity components along the string remain same. This v2 cos theta will be equal to v1 cos theta 1. From here we can easily identify the components of velocity, that is v1 cos theta 1 upon cos theta 2 equal to v1 cos theta 1 into sec theta 2 meter per second. I hope this is a magical instrument that is existing. We need to understand the fact that this is what all about the concepts that is related with this topic. So this is all about the string concept, and in the next video I will be discussing the pulley block system, how the pulley and the blocks are interrelated in terms of velocity and acceleration. Thank you.